In this video, we'll look at a function for Fibonacci series. First of all, I will show you a iterative function that I have explained you in the previous video. I will write a function. I will call the function name as fib. It takes parameter n, that is the term number that we want to find out in the series. So inside the function, first of all, I will write a return 0, because if you see this error message, function is having int return type, but it is not returning anything. So that's what the error is. Control reaches end of non-void function. So to avoid this error, for time being, I will write down return 0. Then later we'll see what we have to return. So this error is gone. Now I will write on the function. I have taken some variables like t0 initialized with 0 and t1 initialized with 1 and s for finding sum, and also we need variable I for for loop. Then the very first thing inside a function is if n is less than or equal to 1, then return same number n. Otherwise we'll find out the term using for loop. So for loop will start I from 2 onwards and I reaches less than or equal to n, then I plus plus. So it will start from 2 and reaches up to the term number, nth term. So every time we have to find out sum, that is by adding t0 and t1. Then t0 should get the value of t1 and t1 should get the value of sum, that is new value that we have obtained. By repeating this loop for n times, we get the result in s. So then last statement should be return s. Earlier I wrote it as 0 to avoid error, return s. Here I am getting a warning that s may be uninitialized when used here. If it doesn't enter into for loop, s will not be modified and s is having some garbage value. So let us initialize s with 0, so this warning will be gone. We'll not get any wrong answers due to this, but to avoid this warning, I have just initialized s to 0. Now inside main function, I will directly print the result obtained by that function, %d and new line. Then I will call the function fib by passing 10. That's all. So now the whole program is ready. I will run the program. Here 10th term is 55. Let us see 5th term. Answer is 5 for 5th term. Yes, the 5th term is 5. Then 6th term is 8. Let us try that also. Yes, I got the result 8. So it's working perfect. Now I will write a recursive function for finding Fibonacci term. Let me call the function name as rfib for recursive. Then parameter is n, that is the term number. As we have already seen the code, if n is less than or equal to 1, then return n itself. Otherwise return rfib of n minus 2 plus rfib of n minus 1. That's all. The function is so simple because it's recursive. It has finished in just 2 lines. Instead of calling fib, I will call rfib here inside the main function. Now let us run program and see what the output is. For this it should get 8. Yes, rfib is also giving 8. Now to reduce this number of calls, we have seen memoization. So I will write on a function using memoization. So already I have one function, that is a iterative function called fib, then recursive function for Fibonacci. Then next I will write a memoization function for Fibonacci. For memoization function, we need one global array f. So I will take the array size as 10, limited size. If you want larger, you can take it. And inside the main function, I will first initialize this array. Using for loop, I will initialize for I assigned 0, I is less than 10, I plus plus. If you remember, the array should be initialized with -1. So all these locations I will fill them with -1. Because 0 is also a Fibonacci term. So we should have the term, so we should have a number, not a Fibonacci term. So -1 is not a Fibonacci term. So I have initialized this array with -1. Now here I will write down a memoization function. That is a function for finding Fibonacci term using memoization. Integer is the return type, so I will call the function name as mfib for memoization. Then it's taking term number n as parameter. First thing is, if n is less than or equal to 1, then in f of n assign n itself and also return n. So these are two statements inside a if condition. So I will write them in flower bracket. So this is the body of if. Then else means if the number is greater than 1, then check if f of n minus 2 is equals to -1. If it is equal to -1, then call mfib of n minus 2. Call this function. And whatever the result we obtained, take it in f of n minus 2. So I am writing in a single line. Okay, I will take it in the next line. Then next one, again for n minus 1 also I have to check it. If f of n minus 1 is equal to -1, then call the function for n minus 1 and take its result in f of n minus 1. So call mfib of n minus 1. Once we have got this result, whether the function is called or not called, we get the results here, then return f of n minus 2 plus f of n minus 1, because the results are kept in a global array f. So that's all. This is a function using memoization. So f is a global array that will help this function to store the results of the function to avoid excessive calls. Now here inside main function, instead of calling rfib, I will call mfib for 5 and I should get the result as 5. I have deleted the breakpoint. Now let us run the program. Yes, the answer is 5. If I call it for 6, then let us see. 8. It's working. Now I will put a breakpoint and debug the function. So you have to count how many function calls it is making. For value 5, it should make 6 calls. I have made the value as 5, so it should make total 6 calls. Run the program. So it has came on this printf function. So you have to watch this watch window and debug navigation to count the number of calls it is making. Let us start. First call, value of n is 5. Second call, value of n is 3. So here you can see the value of n is 3, and here at this place you can see there are 2 calls. So in the previous call, it is in this statement. See, it is in this statement. So 2 calls so far. Then for 3, it has entered inside else block. Then again it is going to call itself for 1, that is 3 minus 2. So this is the third call. For 1, this conditional statement will be true and it will come out of the function after executing this if block. So we are on the third call. Third call has finished. Back on the second call. Now it is entering into second if part of this one. So it will make a call with n minus 1, that is 3 is, that is n is a 3, so 3 minus 1, 2. So for 2, it is a fourth call. For 2, it will enter into else part. Then first if, fifth call. Then second if. it has skipped because already the value of 1 is found. So total 5 calls so far. Then back on 3, so it is making a second part. So for 3, this it has finished, now it's going to call this one. So already fib of 2 is known, so it doesn't make a call. Then back on 5. Now second part of 5. Now this is the 6th call for 4. And for 4, already fib of 2 was known, that is 4 minus 2. So that's why it didn't call this one. Then next, again, this for 3 also, that is 4 minus 1 is a 3. So for this also already value is known. It did not call this one. So total 6 calls so far. Now from 4 it will come out. See, it has not expanded the function call with 4 because already the values were found. Now back on 5th, that is value 5. So it is the first call and it will terminate. So total calls are 6. Only 6 calls it has made and got the result. And if I expand this Fibonacci array, you can see that the values are filled in this one 0, 1, 1, 2, 3. Okay. For 4 and 5, the values are not there because one thing I have missed here, that is inside this, before returning the result, I should fill up the value, that is fib of n should be filled with fib of n minus 2 plus fib of n minus 1. Now let us run the program once again and see how the value of global array f are changing. You can see that the global array is all filled with minus 1. If I continue execution, see, first f of 1 is found. Then f of 0 is found. Then f of 2 is 1 now. F of 3 is 2. F of 4 is 3. Then f of 5 is 5. That's all. So this is how the values are being stored in global array f. So that's all in this video. We have seen 3 different versions of Fibonacci function. One is iterative version and recursive function, and the third one was recursive function with memoization to avoid excessive calls.